everyone, my name is Wen Jing from M6T26. So today I will be showing you the solutions for the question KMPH 2023 to 2024 Set 3. So the question given is Figure 1 below shows a line spectrum of hydrogen atom in the ultraviolet region. So can you guys remember that for ultraviolet region is from which series? The answer is Lyman series. So you guys please remember to memorize the table for each series is from which kind of region in order to answer this kind of subjective question. And you guys please also remember that we have to observe from the larger space to the narrow space for this figure, which is from the lower frequency to the higher frequency. So the frequency will be increases along the way. So the first part of the question asks us to calculate the wavelength in nanometer of photon emitted to produce line B. Please highlight this part as it will be preventing you from making careless mistake. So for Lyman series, the end final will be 1 and then the end initial for line B will be 3. Why? I will be showing you the way to determine the answer now. So we can know that the end final will be equals to 1. So no matter how far you will be reaching for each of the lines, the NF will be equals to 1. So for A, right, this is the first line formed for the line spectrum. So the Ni will be equals to 2, and then line B, it will be from N3 to N equals to 1. So for line B, right, it is written here Ni equals to 3. And now we can write out this formula. And please always remember to write this part, which is Ni is always smaller than N2. And please remember to write out this formula whenever you answer this kind of subjective question, which N1 is always smaller than N2. So after you substitute all these figure inside to the formula, the final answer you will be getting if you click the calculator will be 1.0255 times 10 to the power of -7 meter. And since the question here is asked us to do the wavelength in the form of nanometer, you can click the calculator and you will be getting this answer. So let's proceed to the second part of this question, which we have to calculate the energy of an electron at its excited state before it drops to produce line A. So its excited state, right, it means this the first line. So the first line produced will be N equals to 2 to N equals to 1. So the N initial will be equals to 2. And now we have to calculate the energy of an electron. So we have to use this formula instead for this question this time. Please write out this formula before you answer this question, before it will be allowing you to get 1 mark. So after you do all the calculation, you will be getting -5.45 times 10 to the power of -19 joule. Please always remember to write out the unit, and since the question asks us to do energy and not energy release, so the negative sign, which means release, right, you have to write another row to state that the amount of energy is 5.45 times 10 to the power of -19 joule. And now let's proceed to the B part of this question. The electronic configuration of an atom C is 1s2, 2s2, 2p6, 3s2, 2p6, 4s2, and 3d1. Write a possible set of quantum numbers for the 12th electron. So you can count here. We have 2 here, another 2 here, and then 6 here, and another 2 here. So the 12th electron will be in this part. So write a possible set of quantum numbers for the 12th electron will be N equals to 3, L equals to 0, and since L equals to 0, right, M will only be equals to 0, and you can write either positive 1/2 and negative 1/2. And since the question asks us to write a possible set, so you can either write this one or this one. Please don't write 2 because it will be causing you to get 0 marks. And draw the shape for orbitals. You can choose any one from 5 to draw. And then I choose to draw dz squared. For the rule used to arrange the 6 and 7 electron in the 2p orbitals, please take note the question here is write determine, and for determine it means state, so you can only just proceed to write the answer and not explaining. Proceed to the C part of this question. State the actual electronic configuration of copper. Explain why the expected electronic configuration of copper is different from the actual electronic configuration. So you have to answer 3 parts. The first part is write out the actual electronic configuration, and then the second part is the expected one, and then the third part is to explain. So we can know that copper has 29 proton number from the list which will be given you during PSPM, so we can know that copper has 29 proton number, and now we have to write the expected configuration and actual configuration. Please take note that these two are dots and not equal sign. And after that, we have to explain. Fully filled 3D 10 orbitals have extra stability than partially filled 3D orbital. And please remember that for question that you have to do the comparison, please remember to write the word then and the elaboration. Please do not just write this part because you will not be able to get full marks for this kind of question. So that's all from me. Thank you for having me, and please remember to subscribe.